Okay, now we did the formula for the rate of reaction. Now the next is the different way of expressing the rate of reaction. We have two different methods for expressing the rate of reaction. The one is called average rate of reaction. The rate of reaction is generally represented by a small letter r and then average. And the second method which we have to express the rate of reaction is instantaneous rate of reaction. So we have two different methods, that is average rate of reaction and instantaneous rate of reaction. Now what is the main difference between these two, these two methods of expressing the rate of reaction? In case of average, I can say here the time interval is large. Means here we are observing a reaction for a larger duration. While in case of instantaneous, the time interval is small. So in this case, the time interval is larger one, while in case of instantaneous, the time interval is very small. See, now simply I can say for here we are talking about the rate of reaction, that is the speed of reaction. But when I'm talking about the rate or speed for anything, we have to, for any speed, we have two different methods, that is called as average and instantaneous. For example, in simple words, suppose if I'm driving a car or any vehicle. While driving, we have again two methods for knowing the rate of the speed of that vehicle. The one, first I drive the vehicle for 10 minutes and after 10 minutes I come to know that I covered 10 kilometers. 10 minutes, in 10 minutes 10 kilometer means speed is going to be 60 kilometer per hour. Which I come to know after driving a car for 10 minutes. Now, suppose this is the first case. Now in the second case, I'm driving a car and during driving only I just wanted to know the speed of that car during driving. So during driving, if I wanted to know the speed of a car, then we have an option, that is speedometer. From speedometer, I come to know that the speed of a car is 70 km per hour. How much time it takes for knowing the speed of that car, that is 70 km per hour. Here I just took 1 to 2 seconds to know the speed of car, while in this case, that to know the speed of a car, I took approximately 10 minutes. So here the time interval to know the speed of reaction, here the time interval to know the speed of a car is 10 minutes, that is took a very long time, while here we are getting the same thing but in a very short time, that is 1 to 2 seconds. So in this case, this speed will be called as average speed of a car and this speed will be called as instantaneous speed of a car. So this is an example for the car. Now let's again back to the rate of reaction. Similarly, for the rate of reaction also we are having two methods, that is average and instantaneous. The difference is the same. Here the time interval is large, here the time interval is very small. Here we are observing a reaction for a longer duration, while in this case we wanted to know the rate of reaction for a very short time interval. Now, for example, suppose if I am considering a reaction, the reactant gives product. Now the rate is equal to, I wanted to know the average rate of reaction. Average rate R, this is average rate. The formula as usual, minus delta R upon delta T, that is molar concentration of reactant upon time. Or in terms of product, it is going to be delta P upon delta T, that is change in concentration of product upon time interval. As I said, with the reactant you have to use minus sign, with product there is a no minus sign. Minus sign stands for that as the time increases, the rate of the reactant concentration goes on decreasing. So this is a way how we write the rate of reaction, that is average rate of reaction. Suppose I am considering an example that PCl5 gives PCl3 plus chlorine. PCl5 gives PCl3 plus chlorine. I wanted to know the average rate of this reaction. So R average. Suppose during the reaction, if I measure the concentration of PCl5, then I will calculate the rate of reaction in terms of PCl5. If I measure the concentration of PCl3, I will calculate with the help of this concentration, and if I measure chlorine, then I will write the formula in terms of chlorine. So in terms of PCl5, change in molar concentration of PCl5 upon time interval. Again, since it is a reactant, so you have to use a minus sign. In terms of product, it is going to be PCl3. If I measure the PCl3 concentration upon delta T, and if it is in terms of chlorine, then delta Cl2 upon delta T. So this is the way how we write the average rate of reaction. The delta stands for the large changes, and as I said here, the time interval is large. So large change is represented by the delta, and if the time is large, if I'm observing a reaction for a long time, then change in concentration is also going to be large. Now let's talk about the instantaneous rate of reaction. Instantaneous, where the time interval is very small. Again, I'm considering the same reaction. Let's see how this one is written. So consider a reaction. Reactant gives product. I wanted to now write its instantaneous rate. So instantaneous rate means here the time interval is very small. We are observing a reaction for a very short duration. So if I'm observing a reaction for a very short duration, then the concentration of the reactant which is going to be changed during that small time is also going to be small. So only the difference in these two is that here the changes are large, while in this case the changes are small. Large changes are represented by the delta symbol, while the small changes is represented by D. So it is going to be minus dr by dt. That is change in molar concentration of reactant, again square bracket, that is molar concentration, or in terms of product I said it's a dp upon dt. So again the same example if I'm taking here, then it is going to be PCl5 gives PCl3 plus chlorine, then R instantaneous is equal to minus, if I measure the concentration of PCl5, then minus dPCl5 upon dt. If PCl3 concentration is measured, then it is a PCl3 upon dt. And if the chlorine is measured, then it is going to be dCl2 by dt. That is change in concentration of chlorine upon time interval. So this is only the difference between the average and instantaneous. In writing way, I can say in case of average, we just use a symbol, while in case of instantaneous, we use a small d. Now the question arises that which is more preferable or which gives us the correct value. Now again, to know which gives the correct value, I will again take the example of the same car. See, the car, after 10 minutes driving, I come to know that the car is traveling with the speed of 60 km per hour. But actual thing is that during the 10 minutes, it's not like it throughout the 10 minutes the car travels with the speed of 60 km per hour. In between, it has touched to the speed of 100 km per hour also, as well as it reduces to the 10 km per hour also. Means this value was not fixed, it was continuously varying, and that's why we use the word average. While in case of instantaneous, we observe that speed only for 1 to 2 seconds, but for 1 to 2 seconds the car speed was 70 km per hour, and it was the exact value, that is accurate value. So I can say that instantaneous is always more preferable compared to the average, because it gives the correct value, it always more closer to the accuracy. That's a different thing, that it's for a very small time interval, but the accuracy is more correct or it is more accurate in case of instantaneous. So instantaneous is always more preferable in the case of rate of reaction also. So throughout the chapter we are going to follow this instantaneous only, not the average. Okay, now we have a reaction that is NO2 plus CO gives NO plus CO2. I just wanted to write the rate of reaction. And once throughout the chapter we are going to write the instantaneous, because as I said, the instantaneous is more preferable compared to average. So suppose I am writing the rate of reaction. No need of writing the full word, that is the rate of reaction. Just write rate. It is equal to, in terms of NO2 is a reactant, so it is going to be minus dNO2 by dt. It is equal to, carbon monoxide is a reactant again, so minus dCO by dt. NO is a product, so no need of using minus sign now. So dNO by dt, and then it is equal to dCO2 by dt. Now let's try to understand the meaning of some terms. Suppose if I'm using a word, that is if I'm writing dNO2 by dt, what it mean? dNO2 by dt, D means the change in concentration of NO2 with respect to time. Means here this word represent that change in concentration of NO2 with respect to time. Means with the time how much NO2 is changing. So instead of writing rate of reaction, means it's a rate of reaction, but at the same time I will say it tells us about the change in amount of this with respect to time. That means it tells us about the rate of change of NO2. That means with the time how much NO2 is changing. It tells us about the speed of change of NO2. Now when I'm saying speed of NO2 change, that's change may be increase or it may be decrease. If I'm using a plus sign, it is going to be increase, because with the time plus represent that with the time this NO2 goes on increasing. But if I'm using a minus sign, as we had used in the formula, minus means it tells us that with the time this quantity goes on decreasing. So this change is going to be consumption. That is, during the reaction or during the process, this amount goes on decreasing as the time is increasing. So since it goes on decreasing, means it's a consumption. So it's a rate of consumption of NO2. Similarly, if I'm writing minus dCO by dt, dCO, forget about this minus part, dCO by dt, again it is a rate of change of CO with respect to the time, that is tells us about the speed with which the carbon monoxide is changed. Minus sign, that means it is consumed. So this tells us the rate of consumption of carbon monoxide with respect to time. Then similarly, if I'm writing dNO by dt, there is a no minus sign. No minus sign, that means during the process, with the time this concentration goes on increasing. It means it is a formation, and if it is a formation, it means it is going to be a product. So what it will represent? It represents the rate of formation of NO. Similarly, if I am writing dCO2 by dt, what this represent? Simply I will say dCO2 by dt will represent the rate of formation of carbon dioxide with time. So here this tells us about the rate of consumption of NO. This is the rate of consumption of carbon monoxide, as these two are consumed since they are reactant and these two are forming. So this tells us about the rate of formation of NO, and this tells us about the rate of formation of carbon monoxide. And all these are equal to the rate of reaction. If you'll observe here, the coefficients of all the components are 1 here. And since all are having same coefficient, that's why the rate of consumption of these two and the rate of formation of these two means the rate of all the things are same. And if the coefficient of any component is 1, then in that case the rate of consumption of that particular component is always equal to the rate of reaction. In this case, the coefficients of all the components are 1. So the rate of consumption of these two and the rate of formation of these two is equal to the rate of reaction. Same we did in the last example, that is PCl5 gives PCl3 plus chlorine. In that example also the coefficients were 1, and that's why that formation or consumption rate was equal to the rate of reaction. Now let's talk about some reaction where the coefficients are other than 1. The example, the formation of ammonia by Haber's process, that is N2 plus 3H2 gives 2 moles of ammonia. All are in a gaseous state. So here we have to write the rate of reaction. Now first I wanted to know the speed of all the components, that is the rate of consumption of nitrogen, the rate of consumption of hydrogen, and the rate of formation of ammonia. Ammonia will be formed, it will not consume. So suppose the rate of consumption of nitrogen I wanted to know. Okay, before that, if you can see the coefficients are not 1 for all the components, here the coefficient is 1, in this case the coefficient is 3, and in this case the coefficient is 2. Means in simple word I can say that the rate of consumption or formation of all the components are not same. The reactants are nitrogen and hydrogen, both are having different coefficients. They have a different coefficients, means their consumption rate is not same. Here I can say that if 1 molecule of nitrogen is consumed, then in the same time the 3 molecules of hydrogen, means if 1 nitrogen is reacted, for 1 nitrogen we require 3 hydrogen. It means or if I'm having 100 molecules of nitrogen, then it will require how much molecule of hydrogen? Then simply answer will be 300. It means the rate of consumption of hydrogen is thrice the rate of consumption of nitrogen. Suppose if I'm saying the rate of consumption of nitrogen is, for nitrogen, let example is 10 molar per second. Means the nitrogen is consumed with this speed. Then what will be the rate of consumption of hydrogen? Simply the answer is going to be triple. Because if it is 100, this is going to be 300. So if the speed of nitrogen is 10, then speed of hydrogen consumption will be 30. What will be the rate of formation of ammonia? Again, I will say during the reaction, if 1 molecule of N2 is consumed, then the 2 molecules of ammonia is formed. Means if 100 molecules of nitrogen is consumed, then how many ammonia molecule is forming? It's 200. So if the speed of consumption of nitrogen is 10 molar per second, then ammonia formation speed will be 20 molar per second. Means the hydrogen consumption is triple, while the ammonia formation is double of the rate of consumption of nitrogen. So this coefficients only tells us directly the answer. In MCQ, such type of questions are generally asked. They ask a question like, if the formation of ammonia is 30 molar per second. I'm writing this for ammonia. We will solve example also on the basis of this. If the ammonia formation speed is 30 molar per second, what will be the consumption of hydrogen? Now, we know for the ammonia is how much? It is whatever the speed we are having, it is for 2 moles of ammonia. Better you find out for 1 mole. If for 2 moles it is 30, then for 1 mole ammonia it is going to be 15 molar per second. 15 molar per second. Hydrogen is how many moles? 3 moles. So for hydrogen it is going to be triple. That means 45 molar per second. For nitrogen it is only 1 mole. So for 1 mole ammonia it is 15 molar per second. So for nitrogen again it is going to be 15 only. Suppose I have another example. The example is like the hydrogen consumption speed is 60 molar per second. This is the speed of consumption of hydrogen. It is 60 molar per second. Then what will be the rate of consumption of nitrogen? I will say again for hydrogen in the reaction it represents 3 moles. So for 1 mole it will be how much? 20. Nitrogen is 1 mole. So answer is going to be 20. This is 2 moles. 2 moles means for 1 mole it is going to be 30. So ammonia forming is 2 moles. So ultimately the speed is going to be 60 molar per second. Now let's see how it is written. The rate of consumption of nitrogen. Rate of consumption of nitrogen, if I wanted to measure, simply I will say just find out that how much nitrogen is changed with the time. That means change, so minus dN2. Consumption, it's a consumption, so minus sign upon d2 dt. The rate of consumption of hydrogen. So it is going to be minus dH2 by dt. Again it's a consumption, so minus sign. The rate of formation of ammonia. So rate of formation of ammonia, I can say it's going to be dNH3 by dt. Since the ammonia is forming, that means with the time the ammonia amount or concentration goes on increasing. So there is no need of using minus sign. Now I wanted to write the rate of reaction. Rate. As I said in this example, the rate of reaction is always equal to the rate of the consumption or formation of the reactant or product which is having coefficient 1 mole. Now I know the rate of consumption of nitrogen. This is the rate of consumption of nitrogen. What it is? Minus dN2 by dt. How many moles of N2 is present in the reaction? 1 mole. So since the amount of the moles is 1 or the coefficient is 1, so the rate of reaction and the consumption of nitrogen rate will be same. So nitrogen consumption rate is minus dN2 by dt. For hydrogen, The rate of consumption of hydrogen is minus dH2 by dt. So here I know the consumption rate for hydrogen. I wanted to write the rate of reaction. So simply in the reaction, how many moles of hydrogen? 3 mole. And the rate is equal for 1 mole. So for 1 mole it will be what? 1/3, because it is 3 moles of hydrogen is consumed. So minus 1/3 dH2 by dt. For ammonia I wanted to write. For ammonia I know the formation of ammonia. Its speed is dNH3 by dt. How many moles of ammonia is forming in the reaction? Simply again it is 2 moles. But the rate is always written for 1 mole. So rate of reaction is equivalent to 1 mole. So for 1 mole it is going to be, for 2 mole is this much. So for 1 mole it is going to be half. It means dNH3 by dt. So this is the way how we can write the rate of reaction. Or in a simple word I can say, if you are writing the rate of reaction having a different coefficients, then I will simply say that whatever the coefficients are there, write that coefficient in denominator, like 3 in denominator, 2 in denominator. There is a no coefficient, so there is a no denominator. Means the coefficient is 1. Okay. Now suppose another example having the different coefficient. 2 moles of NO plus O2 gives 2 moles of NO2. Again I will say the consumption of oxygen, it's a 2 moles and this is 1 mole. So consumption of oxygen is half of the consumption of NO. See, we should note that the way of answering directly, it will help us to write the answer in MCQs without solving or without writing all those formulas. So I can say with what speed what is the relation between the rate of consumption of NO and O2? It's a 2:1. 2:1 means this is the rate of consumption of oxygen is going to be half of the rate of consumption of NO. Similarly, suppose if I know the consumption speed for oxygen, then I can write for NO2. How much it is going to be? If it is 5 molar per second, this is going to be 10 molar per second, that is double. Suppose I wanted to write the same thing again, rate of consumption of NO. So it is going to be minus dNO by dt. The rate of consumption of oxygen so it is going to be minus dO2 by dt. Rate of formation of NO2 and since it's a formation, so it is going to be dNO2 by dt, no minus sign. Again, I wanted to write the rate of reaction, the speed of reaction. So rate is equal to, this is 2 moles, so rate is going to be, it is actually for 1 mole, so it is going to be half of the rate of consumption of NO, that is minus dNO by dt. 1 mole, so it is going to be minus dO2 by dt. And this is for 2 moles of NO2. The speed is for 2 moles of NO2. The rate is always for 1 mole. So it is going to be minus dNO2 half of dNO2 by dt. So this is a way how we write the rate of reaction. Just keep in mind that if there is some coefficient, then while writing the rate of reaction, coefficients are always written in denominator. And if the coefficient is 1, then there is a nothing is in denominator.